Hi, my name is Molly Johnson, and this is my AE 1601 glider project. So to start off, we had a few building requirements for the project, as well as some flight restrictions. For the building requirements, the sizing, it must fit within a 16 by 16 inch box, and the overall weight cannot exceed the lift force, meaning that the glider actually had to fly. You couldn't just throw it across the field. The materials had to be lightweight enough to fly and also made from household objects. We were advised to not spend any money buying unnecessary materials, so I created my glider out of the things that I was given and things that were available to me at the makerspace. For the process, we had to have at least one design change. For the flight restrictions, flying, it had to be hand-thrown, which means no propulsive devices and no automatic controlling devices, and the goal was 20 feet in normal outdoor conditions horizontally. The landing, it had to land intact and must also be able to be thrown multiple times for the tournament aspect of the flight. My initial design. So the original materials that I was planning on using was the balsa wood plank that I was given, disposable wooden chopsticks, and for adhesives, super glue and duct tape. This is the original design for my first design. As you can see, I drew it to scale. All the dimensions are here. Starting with the wing shape, I have a tapered leading edge and a straight trailing edge. This is because a tapered leading edge and straight trailing edge has less wing area, as you can see, compared to a rectangular wing. And this was to lower the wing area, which would increase the aspect ratio. For the fuselage would be made out of a chopstick, which is naturally unbalanced. As you can see, it's more tapered at the end here. And I would sand the nose to make it less rectangular and to reduce drag. The fuselage length was 8 inches, and the wingspan to fuselage ratio is about 1.5. For the back fins would obviously be smaller than the front wings, and I kind of estimated the size to see what would work during testing and what would not. The wings were made out of balsa wood as well. The aspect ratio, as you can see, the equation is up here. The wingspan was 12 inches and the wing area was 15 inches, so the aspect ratio was 9.6. Typically, gliders have a higher aspect ratio, which is why I was trying to lessen the wing area in order to get this number to be higher. Part 2, assembly. So I reserved a spot in the makerspace and I brought with me my wooden plank and chopsticks that I stole from Willage. But instead of super glue and duct tape, I decided that super glue might not hold as well and duct tape might be a little bit too heavy. So instead I used wood glue and masking tape. So I cut out everything and assembled it at the makerspace. Unfortunately, I ran out of time for my time slot before I could balance it there, so I had to balance it at home. As you can see, the image on the left is unbalanced, but it is balanced on the right when I have a little piece of tape here. I also had to add a little bit of tape on the nose, which I'll get to in a second. And one design modification is that originally I designed the wing to be in 2 pieces, but I figured it would be easier to adhere if it was in 1 piece. So now the wing is 1 piece instead of 2. So test flights and design modifications. This is a picture of my apartment. I had to have my roommate help me hand measure this with a ruler, so it's about 20 feet from end to end. This is the straight-on view versus the side view. I had to use a panoramic to get the whole image, so ignore the curvature in the picture. So here is why I put tape on the wing. So without tape on the wing, the glider was not balanced and this created roll, and too much roll made it crash into the couch and crash into the wall. However, once it was balanced with tape on the wing, there was significantly less roll and the glider continued to fly straight. For adding mass on the nose, as you can see, the original center of gravity is about here, about the middle of the chopstick, which was too far backwards, so I had to add mass to the nose of the glider to move the center of gravity a little bit further forward, so it's about the quarter chord of the wing. I used Play-Doh to kind of test to see what is too much mass, what is too less. As you can see, with no weight on the nose was the red path here, and it would kind of nosedive immediately, or stall and nosedive. With insufficient mass, it would do the same thing. It would go a little bit further, but still crash. With too much, it would immediately pitch forward and nosedive. However, with the balanced amount, that's this green path here, you can see it flies across the room, which is what I wanted. So here's my final design. Instead of using Play-Doh, which kind of deformed every time it hit the ground, I used the approximate mass but in masking tape and attached it that way. Here I just wanted to point out, you can see the visible effects of air resistance on the tape. It's not completely smooth, and that's because air kind of drags across the tape as it flies. And also I wanted to point out there was a little bit of flight damage to my glider when I was testing it. So for throwing tests, I figured my glider flew the best when I threw it from about here of the body. And for angle of attack, here's 0, 15, and 30 degrees. The testing at 0 degrees, just throwing it straight forward, it would go far, but not quite as far as 20 feet. As you can see, there was no upward trajectory. However, between 0 and 15 degrees was mostly ideal. Anything over 15 degrees, it immediately kind of pitched backwards and then stalled and fell. So for the fly off, my total distance was only a foot. Unfortunately, it didn't go as planned. I didn't throw it as I had practiced, and also it caught a little gust of wind. So it flew forward, but then kind of spiraled backwards. So my total distance was 1 foot. However, in this video, after the throw, the tournament, you can see it does go over 20 feet. This is actually technically 23 feet. So for lift and drag calculations, for lift, I used the equation shown in the aerodynamics lecture. So I found the angle of attack, which was about 7 degrees from the video, transformed that into radians, and then did the following calculations to get my lift coefficient of 0.768. Similarly, for the drag coefficient, my drag coefficient is somewhere between 0.5 and 0.82, and this is because my wing is designed like this, which is not technically a perfect rectangle, but also not a perfect triangle either. So it's somewhere between this rectangular value 0.82 and this triangular conical value 0.5. Reflection. So things to improve, if I had to do this again, I would probably design my glider to be a lot larger than I originally did. When I showed up, a lot of people's gliders were much bigger than mine. I would also try to add a dihedral if I had the materials to measure angles more accurately or modify my wingtips. I would shorten my fuselage, and I would also try to move the center of gravity a little bit more further forward in order for more consistent throws. And here are my references. And that's it. Thank you for watching.